floor.
Okay.
Which is nice because there's like 20 of us, even though we only stay together, so.
Now, which dorm is that?
Shenandoah Hall, it's in East Campus.
Okay.
Yeah.
That's right by E Hall?
Yep,
Okay.
it's,
Well, that's
yeah, it's one of those three.
one of those three, not the newest dorm, but not Jennings, the one.
Oh, yeah, no.
Okay, that's.
Yeah, Jennings has like hardwood floors and has like a cafe below
No
it.
way.
Yeah, it's like a
Nice.
bougie hotel.
No, that's, and you guys get stuck in Shenandoah.
Yeah.
But it's closer, I think it's closer to a lot of things. So.
Yeah, Jennings is like the farthest away from everything, which is I think why they have a cafe underneath, because their walk everywhere else is so much longer than ours is.
Right, that's,
Yeah.
that's. Oh. So now, how about at home, is everybody healthy at home?
Yeah, I'm kind of surprised too, because when I went home for the weekend, I went to one of my brother's soccer practices, and nobody there was wearing a mask. Like the parents weren't,
No
the
way.
kids weren't, and my parents are like very conscious about it because my dad is high risk, and I was like, Dad, what the heck is going on here? And he's like, well, it's been 5 weeks since they practiced like this, and only one kid thought that he had COVID, so they sent him home, and then they canceled practice for a week, but then everybody else was fine.
Okay.
And I was like, well, okay, I mean, like,
Yeah,
just
it's like-
keep being safe, but when
Yeah.
I came back home, I was like, everybody wear your mask. I was like, I have to go back to school.
No,
I was
right.
like,
You
better
don't
wear
understand.
yours.
I'm in the cesspool of COVID
Yeah.
here at JMU. So,
Just wait till Halloween.
oh, that's what I'm, yeah, Mason, I am terrified about Halloween.
We're gonna get screwed.
Yeah, I just don't see how the people are gonna social distance.
I already know kids from like Virginia Tech and UVA coming here. Like they're already making their plans to stay at their friends' houses off campus.
Really?
And apartments are already planning to come here for Halloween.
Okay, that's,
I was like,
yeah, normally this place is jammed, with gatherings.
yes,
We'll just use the word gatherings lightly. Usually this campus is slammed with gatherings. I mean,
under 10 people, right?
Oh, yeah, of course,
Oh.
under 10 people, yeah, that's,
There's just multiple
Yeah,
gatherings of
there's-
under
it just,
10
it
people.
just so happens there's 10 gatherings.
Oh,
of
10 people.
in one house.
We should do that in a math problem. We'd be like, okay, if you're going from here to here.
that's.
So if you're going from this party to this party, and the probability of getting
Yeah.
COVID is
Probably getting
28.9%.
Yeah, that's, by the end of the night, what's your chances you would have COVID?
100%.
That's, now Mason, are you a freshman also?
No, I'm a sophomore.
A sophomore, okay. Are you living off campus or on campus?
I'm in Jennings.
Oh, you're in Jennings, that's right. The hotel, the
Yeah,
posh hotel,
yeah.
that's,
That's what it is.
that's, now, are those suite rooms or are they regular rooms?
They're regular.
Okay. But rooms with a view, your rooms with a view.
Oh yeah, I got a glorious view of that power station.
Oh, you gotta be kidding me, that's your
It's
view?
great. Let me tell you, I can see
Oh, gosh.
I can see bioscience,
So you-
Shenandoah, and the power
The
station.
drainage pit there
Yeah.
and the power station. I mean, I just like, why don't they tear that, because it was a place where they would burn garbage to get power. That's what it started as.
That sounds.
Horrible.
And then they realized that was bad for the environment and that was bad for like, everything else. Okay.
They couldn't get enough garbage to make it profitable. They couldn't get enough garbage to burn to make it profitable.
It's in a college campus. What?
Yeah,
I
no,
don't see why
yeah.
not. Burning tires is a perfect.
Yeah, no, I saw it. So yeah, but it would smell over there, it was,
Oh.
yeah, so it was bad, it was bad. But it's still such an ugly building, it's just such an ugly building, that's the, so you're on that side of Jennings.
Yeah.
So you got gypped, it was like, which floor?
Fourth,
Is that the highest floor? or
second to highest.
Second highest.
I mean, the view, in the main, that big center
Yeah.
area is great, but
Okay.
most of the rooms don't have, unless you're like on the back side of the building.
You don't have.
None of the buildings really have, or none of the rooms really have. a view.
Okay, okay. Remind me to tell everybody, oh, I didn't start Zoom. I'm a mess. Oh,
That's okay, Dr. Warren, technically you have 2 minutes.
yes, there we go. People are gonna be like.
Mhm.
What the frick is that?
Some giant bug.
It's a bug.
Yeah, it looks like a stick.
Can I kill it?
No,
Why not?
don't kill it.
Dr. Warren is a bug.
We don't kill it.
Why, are you gonna get it out of the room?
Well, I can try
It's
to
a
if that's the
grasshopper.
alternative.
Oh, hell no, I will step on
Just chilling.
Get a cup.
Oh my
Well,
god,
then
do you
have
have
a
a
little
cup?
grasshopper stain on the carpet.
I have a
You know the
Ziploc
part from the
bag.
Lorax where he's like, let it die, and then he's like,
Ziploc.
stuck in the ground? That would be me.
I think that may be the entire Greek culture. Well, where is everybody? Where is everybody? There's 35 students in class.
Just looking at.
1, 2.
2, 3, 4, 5, I've got, okay, there's
I count 11 total.
Nicholas,
That's an
Nicholas,
amazing
yeah.
Little shop.
Is it dead? Is it alive?
It's
No,
not
I'm pretty
moving.
sure it's alive.
Nicholas, are you in theater? Are you in musicals?
Oh, are you talking about like my college?
Yeah.
Yeah, yeah, that was my musical, my junior year of high school.
Okay, what show was that?
Workshop of Horrors,
Little Shop of Horrors, oh, nice.
yeah.
No, because I don't want to go over to a place and have it stomp on.
All right, guys, I guess we should get started. I don't know where everybody else is, hopefully
It's gonna jump on you.
Hopefully I will get We're having, there's a grasshopper in the classroom. There's a grasshopper in the classroom.
Alright, you better get it before I actually stomp on it.
It's gonna jump on me.
Yes.
Let it jump on you.
Okay, I guess, let's get your cameras on. I don't know where everybody else is. We have a what next Friday?
A quest?
A quest, yes. You guys have this spiritual ability about you, yeah. We have a quest when?
Next
Next Friday, okay, I'll talk about sections Friday or Monday, depending on which ones we are. Okay, stand up, let's get our brains turned on.
It's gonna jump right on me.
Let's turn on our brains, Okay, I guess let's just run in place, come on. Jumping jacks. Zach, you're doing nothing. Colin, where's your face? Lindsay, Henry, Trey, Christopher, I can't see you guys, okay.
You just said
Yes,
it.
wheelchair. Okay, let's sit down, let's see what you learned last time. Okay, if I was gonna ask you next Friday on our quest, our third quest, if I was gonna ask you to find the average rate of change of a function on the interval a to b, what formula would you want to have written down? If I wanted the average rate of change of a function on the interval a to b, write down what's in your gray matter. The average rate of change of a function on the interval a to b. Without looking at your notes. Okay, go to grid view. And guys, some of you guys don't have your pictures up. They're not gonna be able to help. There's only 4 people with their pictures up. Now hold up what you have so other people can see. hold up what you have on your thing so other people can, you guys hold up in the room what, show each other what you have, show each other what you have, show each other what you have. Okay, very good, Lorelei, very good. So the formula you want to have memorized is what by next Friday? If I say average, the average rate of change of f on the closed interval AB, the average rate of change of f on the, what is the formula?
F of B minus F of A over B minus A.
Over B minus A. Now notice the units of this average rate of change. Forgot the average rate of change. That's average rate of change. The average rate of change, the units are my range units over my domain units. It's what's coming out of the function divided by what's going into the function. So like for example, suppose x has units of beer cans, and f of x has units of ounces of vomit.
Ew. Dr. Warren.
Sorry. I know we're not being correct here. And I'm recording it, so. Okay. X has units of beer cans, and f of x has units of
Ounces of vomit.
ounces of throw. And so if I say f of 10 equals 30, interpret that for me. If I say f of 10 equals 30, interpret that for me.
30 ounces of vomit for 10 beer cans.
At 10 beer cans, I've got 30 ounces of vomit. Now, so imagine that we do this. Okay, you would be dead. Let's just stop right there. Okay, as I'm teaching now. Okay, if you drink 20 beers, no, never. Do we understand this?
Yeah.
Unless it's O'Doul's. Okay? O'Doul's maybe, okay? Even then, you're probably gonna drown yourself in 20, okay? So, but let's just imagine we had this. Interpret that for me. Interpret that for me.
20 beer cans. will be
At 20
100.
beer cans, you've got
100
ounces of vomit. 100 ounces of vomit. Okay, so now imagine I said, what's the average rate of change in vomit as we go from 10 beer cans to 20 beer cans? Could you calculate that?
Yeah.
Could you
Yes.
so go ahead and calculate that. If I say, what's the average rate of change in vomit as I move from 10 beer cans to 20 beer cans? And so it would be, using the flashcard, it would be f of 20 minus f of 10 divided by 20 minus 10. But f of 20, how much vomit did I have? 100 ounces minus 30 ounces divided by 10. Now everybody should be able to do that math. Everybody should be able to do that math. When you simplify this, make your teachers back in high school proud. What do you get? 7. Now what are the units of that 7? What are the units of that 7? Well, it's range units divided by domain units. So it would be
Ounces of vomit per beer can.
ounces of vomit per can. So on average, the amount of vomit is increasing at a rate of, the average rate of change in vomit is increasing at a rate of 7 ounces per can. Do you guys get a sense that this could get used for any application other than beer and vomit? Do you get an idea that this might be important in business? If it's dollars per unit, and so on. Okay, now one of your web assigns, which is due when? Friday, at what time? Midnight, yeah, okay. 11:59, because I never get AM and PM right. I mean, I don't want to have it due, okay, at AM when it's maybe supposed to be PM, or PM when it's supposed to be AM. So it's due at 11:59 PM, 11:59 PM. One of the questions asks this. They give you a function. Now, can you guys read this at home? Can you read that function? Can you read that? What does that say?
Yeah, that sounds good.
F of t equals 2t squared
Plus 48T.
plus 48t. Very good. F of t equals 2t squared plus 48t. Okay, and then we have t is measured in seconds, and f of t is measured in feet. And guys, I just want to put it out there. I just want to put this out there. I think there's enough space in this classroom, given the amount of attendance that I've had. I think there's enough space. If you're the kind of student that, like Dr. Warren, I'm so tired of having cataracts in my eyes, of seeing a video. I'd really like to come to class every day. I really think there's enough room in this room. I mean, if you want to come to class every day and be in the classroom, come. I'm almost certain I won't have to turn you away. Okay, so I just want to put it out there. Okay, if you're like, I don't want to be Zooming anymore, I want to be in class, come to class. Some of you are like, I'd rather do Zoom. And then some of you are watching the video and not coming to either. And I don't like that. I want you in Zoom or in class. Because there's so much in the volleying. I hit you. I hit you. Return. I hit you.
Return.
It's so much in that. When you're in camera, Leanne, I hit, and you're out drinking on. You're out. Who knows what you're doing? I don't know what you're doing. If you're a senior, I don't know what you're doing. Maybe you're down at Billy Jack's. Watching it on your phone. I have no idea what you're doing. And some of you are like, what's Billy Jack's? The freshmen are like what? You don't want to know what Billy Jack's is. Okay. So this is like one of the WebAssigns. It says find the average velocity, which really means find the average rate of change, which means use this formula. Now here's my function. Can you guys hear me in the grid? Is it my auto? And how about you guys hear it?
Yep.
This crazy mask, I'm never quite sure how. So at t seconds I'm at f of t feet. At t seconds I'm at f of t feet. So I'm saying on the interval 20 to 21, find the average rate of change. But we're not done. I also need you to do it on the interval 20 to 20.1, a very small interval. And then I need you to find it on the interval 20.01. Now, because this is class and this is not homework, I'm only going to do one of them. I'm going to find the average rate of change. On one of these. Which interval do you want me to do it on? Do you want me to do it on the first interval, the second interval, or the third interval?
The third.
You want me to use the third interval? Okay, so let's do that. It would be who's the A and who's the B. You've got the flashcard down. Help me out. Who's the A and who's the B in this third interval?
The A is 20.
The A is 20. And who's the B?
20.01.
20.01. So now I just remember my flashcard. F of 20.01 minus F of 20, all divided by
20.01 minus 20.
20.01 minus 20. Now you grab your calculator. And you plug these numbers into your function, which is right here. Now I've done that already before class. I did that before class. F of 20 is 2 times 20 squared plus 48 times 20. The calculator said it was 1,760. Now 20.01, I plug 20.01, square it, 20.01 times 48, multiply that times 2, and I get
1,761.28.
1,761.28. So then if I'm looking at my average rate of change, what would go in this location? What would go in this location? What would go in this location?
1,761.28.
Minus, what goes in this location? What goes in this location?
1,760.
1,760.
And then you guys do the math. I know this is gonna be hard.
0.0.
What is 20.01 minus 20?
0.01.
0.01. Okay, now, what is 1761.28 minus 1760?
1.28.
1.28. Okay, now what is 1.28? What is 1.28 minus, divided by 0.01? Now, should you be able to do this without a calculator?
Yeah.
Should you? You should. What does 0.01 mean as a fraction?
Oh, you usually move the decimal.
Are you gonna have children someday? And I know you're gonna say no. Yes, you are. I said no. I've got 5. I said no. They trick you. They say they need playmates. But how many realize, brothers and sisters, they're not playmates. They're fight mates. That's what they are. They're fight mates. You might as well turn the rooms into an octagon and just sell tickets. Anybody been in the car? Anybody been on a family vacation with a brother and sister? Did anybody draw a line on a seat and threaten their brother and sister if they crossed that line,
Yep.
there was going to be blood to pay?
No, we got along.
Yeah.
I have 2 brothers, so I have a pillow in between.
So yeah, I'm just saying. So what does this end up being? What does this end up being?
128.
128. What are the units of that 128? What are the units of that 128?
Seconds per feet.
Feet per second.
Feet per
Oh,
second.
feet per seconds, my bad.
The range is feet. The domain is seconds. So it's feet per second. How many people feel like they can do this? How many people feel like they can do this? So linebackers, I used to be a football coach. I know it's hard to believe. I used to be a football coach.
Is it hard to believe?
Well, I mean, look at me. Do I look like a successful athlete to any of you?
It does-
No.
You look like the coach though. That's all.
Maybe I could look like a coach. My biggest problem is I was too aggressive. That was the problem. And back in the 80s, you could like grab a kid's face mask who didn't do well on the field for you, and you could be like in their face saying, you know, some things that probably weren't real good to say to a 9th grader at that point in time. You know, like, how many times do I have to tell you, don't get beat deep. Push it inside. Don't get beat on the sidelines. My linebackers, I'm telling them, I mean, they're 9th graders. I'm like, okay, you got a quarterback, you mimic the quarterback, middle linebacker. If they step back, you step back. Okay, if he moves this way, you move that way. Mimic the quarterback. And then these stupid linebacker, my lovely little linebacker goes here, the guy dumps it over the middle, touchdown. But enough, okay. Little linebackers, when I say average rate of change, what do you write down?
F of B minus F of A over B minus A.
When I say tangent line, what do you write down?
Y minus F of C equals F prime of C times X minus C.
Okay, good, okay. All right, now, the question didn't end with this. It asked, what is the instantaneous rate of change at t equals 20? The question didn't just ask me these 3 questions. It asked me also for the instantaneous rate of change. What's the instantaneous rate of change. Oh my gosh. Can't win that. At t equals 20. Now, how many people recognize this as a different question? How many people can say that I could recognize that to be a different question? Raise your hand, raise your hand. How many people could recognize, Colin, I can't see your hand, but I'm believing it is in the air. Colin, are you really there? Or are you off some? Okay, good. James, how about you? Are you really there? James, are you really there? Can I see a thumb, James? James, where the hell are you? James, are you pretending to be in class? Do you have a freaking frisbee in your hand, James? James.
Hey, he might just be going to the bathroom. You should ask in like 5 minutes.
James, if you go to the bathroom, man, take your laptop with you. Why would you miss that? You don't have your camera on anyhow. Just keep your mic off. Okay. So here we go. I mean, yeah, I know you need a break here. Just okay. I mean, I don't quite get it. Like my daughters were telling me this. That I'm like, sweetie, why don't people flush the toilets anymore? That's why I asked. Why? When I go in the bathroom and I go to the men's bathroom in the urinals, and it's just full of pee, and I'm just
Dr.
like,
Warren,
that's
you
the
said
point.
the
Yeah,
men's
men's bathroom.
bathroom.
oh, sorry, the men's bathroom. Okay, why don't they flush the toilets anymore? And I'm just like, I just don't get it. And then my daughter goes, Dad, the water shortage. You know, if it's yellow, let it mellow. If it's brown, flush it down. And I'm like, sweetie, it's a urinal. If I see brown in a urinal, I'm not flushing it down. I'm running away. If I see somebody putting brown in a urinal, I'm calling the cops. If it's yellow, let it mellow. It would never get flushed. Okay. How many people recognize instantaneous rate of change is different than average rate of change? Now here's the thing, in this book, they don't even use the word instantaneous. They just say rate of change. So whenever in this book you hear the word rate of change, say that.
Right.
Rate of change.
They're talking about the instantaneous rate of change.
Ah.
And what they want there is what we were talking about last time, the derivative. So when they're talking about that, what they want is the derivative. The derivative gives the instantaneous rate of change. The derivative gives the rate of change. So you're looking back here. How many people are terrified of taking the derivative of that function? How many people are terrified of taking, how many people like, Dr. Warren put that on the quest? How many people think they could take the derivative of that function? What is the derivative? I guess the variable is t. What is the derivative of f prime of t? What is the derivative of f prime of t?
14 plus
14.
No,
Or
14.
4t plus
48.
48. Now they want the rate of change at 20. So then I do f prime of 20, which would be 4 times 20 plus 48. 4 times 20 is 80 plus 48 is 128. And that's the instantaneous. That's the instantaneous rate of change.
Dr. Warren, on your quest, are you going to ever write just rate of change, or would you always write instantaneous rate of change?
That's a great question, Alex. I will be very specific about instantaneous rate of change because I don't want you to get confused. When you hear average rate of change, is it different than instantaneous rate of change?
Yes.
Yes.
And I just want to make sure you guys are all on the same page with that. If I wrote a book, I would do the same thing. Okay, good, just making sure. I'm talking about vomit and beer, and I'm talking about urinals. Oh crap, I'm videoing it.
Are you not allowed to close the doors?
I'm not supposed to close the doors.
Okay.
Because, yeah,
COVID.
if I close the doors, then we're in a dangerous place of getting COVID.
Okay.
But if I leave the door open, we're completely safe.
Right.
You know, we're totally
Check
safe.
marks.
That's like the green check, yeah. The green check.
Thank you, board.
Yeah, well, How many people forget to do the Live Safe app? How many people, am I the only person that forgets the Live Safe app every stinking
If
day?
you're on campus, you have to do it though, like if you're eating on campus and stuff,
Oh.
so.
Okay.
Yeah, well, no, but then they just do it like right outside of the
Yeah.
dining hall.
And
Instead
they
of
do
in
it
their
like 3
room.
seconds. It's easier to just do the little survey again than it is to go to your email. and
Yes.
find it.
Seriously,
It
yeah.
is.
You know, I wondered like if I could
I
just
just
have a
screenshot
picture,
it.
take a screenshot and just hold that up
Yeah.
every time.
Mhm.
Okay,
They check the date.
this is bad. Why am I teaching you bad things? Okay.
Well, it shows the date, so some
Yeah,
people
they do
actually
check
check
the
through the
date.
date.
Every morning, you take it, you do it, you take a picture, you print it out, and you just have like a little ID card with the.
Yeah.
Okay, back to where we were here. What are the units of the 128? And you're like, Dr. Warren, let's think about it.
Oh.
What is f prime of c?
The derivative of C.
Oh, good,
I was,
good. How's this defined? How's this defined? Have we forgotten already? Have I taught you nothing? The limit as
X approaches C.
limit as x approaches c of f of x
minus f of C.
over x minus c. How many people remember that? How many people like remember that? Okay, now you help me out. X and c are coming from which of the function? The domain or the range?
The
X and c are coming from where?
The domain.
Domain. F of x and f of c are coming from what?
The range.
The range. Is it not the same? Is it not the same as the average rate of change? Aren't the units the same as the average rate of change? And so this would be 128, for this problem, this would be 128 feet per second. And this is the most important application of the derivative, not feet per second. I mean, not rate of change. How is the domain and range affecting each other? How is the range changing with respect to the domain? This is where the application of the derivative is so important. Let's talk about business. Suppose f of t, this is time in years, or maybe days. And what's coming out of the function is profit in dollars. Do you think we would want to know how the profit is changing with respect to time? Do you think we'd want to know how profit is changing with respect to time?
Yes.
Well, what would the units of the derivative be? What would the units of the derivative be? What's going in? Time in, days. What's coming out?
Money.
Money. So the units would be
Line.
dollars per day. The units would be dollars per day. Do you see how this has application everywhere? Do you see how this has application everywhere? Okay, blood pressure per blood pressure pill. Blood pressure per blood pressure pill. Okay? You can't OD on ibuprofen. I don't know if you knew that or not. You can't. You can destroy your stomach, but you can't OD on ibuprofen. Okay, but can you OD on alcohol?
Yes.
Can you OD on alcohol? And so we could talk about breathing versus ounces of alcohol. Breathing versus ounces of alcohol. They're everything. You give me a scenario, I can make up a model for it, a mathematical model. And I can use it. I can use this concept of calculus. Newton was where in Man of the Millennium? 2. Number 2. Out of all the men in 1,000 years. Is that pretty good?
Yeah.
Yeah, I mean, okay. Stand up again. Stand up again. Okay, sit back down. Sit back. Now I'm gonna go share my screen, and you guys will look up here.
Yeah, like,
You need to ask James if he's here or not.
James, are you here, man? Am I getting a pulse?
Yeah, but,
Okay.
yeah, I emailed you, I don't know if you noticed, I actually have a concussion.
Oh, James.
Dr.
sorry, man.
Warren.
Sorry,
I was there
James.
Saturday. with
No, I-
Postcode. I'm okay though.
You were where?
I don't know if you remember what happened Saturday morning with the explosion in Harrisburg.
Yes, I think the whole town knows, yes.
15, 20 feet away from the building.
You were 20 feet away from the building?
So you were one of the people.
I was the closest one. I was one of the closest people. I was the closest one to the building, actually.
Oh my.
So, I'm okay.
Are you sure you're okay, James?
Yeah, I'm sure. I've been to the doctor. I was checked out and everything.
Okay,
Dr. Ward,
okay.
you really asked me if he was here like this. This man is like, get
Sorry,
out
James,
here.
I was just throwing you under the bus, and you've been thrown under a building.
Imagine that, one of your students survived an explosion.
It's 2020. It's,
Oh
Yeah, Jeez.
Glad you're okay, James.
I'm glad you're okay, James.
Thank you, Dr. Ward.
Here we go, okay. All right, let's imagine that we're looking at problem 32. Can you guys see problem 32? Can you guys at home see 32? Can you guys on the grid,
Yeah.
can you see it? Okay, the velocity of a hot air balloon rises vertically from the ground so that its height after t seconds is h equals 1/2 t squared plus 1/2 t feet. Okay, so what's the domain units? What's the domain units?
0 to 60
0 to 60 what?
seconds.
Seconds. What's the range units? What's coming out of the function?
Height.
The height in feet. It says, what is the height of the balloon at 40 seconds? So how would you solve that? Well,
Find
h is giving you
the
height at time t, so you would just take the 40 and plug it in for t.
Yeah.
So it'd be 1/2 40 squared plus 1/2 times
40.
40. Could you guys do this with a calculator? Could you do
Yeah.
that with a calculator?
Yeah.
Yeah.
Okay, the next question is, what is the average velocity of the balloon between t equals 0 and t equals 40? What formula do you write down?
F of B minus F of A over B minus A.
So you would do the h of 40 minus the h of 0
Over 40 minus
over 40 minus 0. Now it asks for the velocity, which is the instantaneous rate of change.
Take the
at 40.
derivative. And then
You would then take the
derivative.
derivative. Could you guys take the derivative of this function without a lot
Yeah.
of difficulty?
Yeah.
So what would the derivative be?
2 plus 1.
What would the derivative be if you took the derivative?
T plus 1/2.
T plus 1/2. And then you plug in the 40. Okay, so now let's look at problem 35. Read this to me, so you don't have to listen to me read.
The quarterly profit in thousands of dollars of Cunningham is given by P of X equals negative 1/3 x squared plus 7x plus 30 from 0 is less than or equal to x, which is less than or equal to 50.
Okay, so this says the quarterly profit given in thousands of dollars. So whatever number comes out of this P of X, we multiply times thousands of dollars. X is actually thousands of dollars also. So my units are going to be dollars per dollar. So this is a little bit different, it's going to be dollars per dollars. Now it's asking, what is the rate of change? Now in this book, when they say rate of change, I want you guys interpreting that as
That's the word I almost killed it.
instantaneous rate of change. Or did I almost kill it?
Oh no, it's over there now.
Okay.
Wow, it's moving.
Oh, no, it's like a chapter.
Yeah, Dr. Warren was that on like 4 times.
Could you guys take the derivative of this function? Could you guys take the
Yes.
derivative? And then all they want you to do is plug in 10 and plug in 30. Okay, last one. Number 38. Under a set of controlled laboratory conditions, the size of the population of a certain bacteria culture in T minutes is described by the function f of t equals 3t squared plus 2t plus 1. Find the rate of the population growth at t equals 10 minutes. So what's going in? They don't talk about units necessarily, it's just number of bacteria. The domain has units of minutes. And they want you to find the rate of change at 10 minutes. So what would you do?
Take the derivative.
Take the derivative and plug in the number 10, and you're done. Are you guys getting this? Are you guys getting
Yeah.
this? Is this making sense?
Yeah.
Okay, I'm gonna give you a question. Here we go. Okay, here's my model. Okay, let's see, what is it modeling? Let's,
Kids in class per grade.
kids in class per grade. Oh, I need something more fun.
That's
What
just
do you got?
fun.
I do scared me. I thought it was like hopped on him or something.
Okay, so Henry, just give me any units you've got. Anything. It can be the most make-up thing. You got anything for me?
I honestly don't have anything for you.
Lorelei, what do you got?
Duke dogs.
Duke dogs. Okay, so what's going into the function is Duke dogs.
Oh, what's coming out of it?
Live safe.
Okay, what's coming out of our function?
The green check marks.
Green checks.
Green checks. Okay. Okay. Now, if I said, what's the instantaneous rate of change in green check marks at,
Can you read what the function is?
yes, thank you. It's the numerator, it's a fraction. The numerator is x squared plus 2x plus 5. And the denominator is x squared plus 4x plus 1. And I want you guys to find the instantaneous rate of change in the green check marks at x equals 3 Duke dogs. Do that. Find the instantaneous rate of change. The rate of change in the number of green check marks at 3 Duke dogs for this mathematical model. James, you don't have to think at all. You should just.
Thank you, I appreciate it.
I guess for sake of time, I gotta stop you. For sake of time, I gotta stop you. What's the first thing you did? What's the first thing you did? What's the first thing you did? Take the derivative. How many people took the derivative? How many people? What rule do you want to use to take the derivative? What rules? Quotient rule. So let's do that. If I use quotient rule, what's going to be on the bottom? What's going to be on the bottom?
X squared plus
X squared
4x
plus
plus 1 squared.
1 squared.
Yes, x squared plus 4x plus 1 squared. I'm done with that. Now let's talk about the numerator. What's the derivative of the numerator?
2x plus 2.
2x plus 2 times x squared plus 4x
Plus
plus
1.
1 minus
2x plus 4.
and I'll put that at the end here. No, that's good. That's good. There's 2x plus 4, the derivative of the denominator, times the numerator.
X squared plus 2x plus 5.
Now what do you do? Now what do you do? Now what do you do?
Can you just plug in a 3?
Wherever you see an x, you're going to put a
3.
You're going to put a 3. Wherever you see an x, you're going to put a 3. So f prime of 3 would be equal to, now you guys are going to help me out. What is 2 times 3 plus 1?
Wait, plus 2?
Sorry, what is 2 times 3 plus 2?
8.
8. Now, what is 3 squared plus
12.
4 times 3 plus 1?
22.
22 minus 3 squared plus 2 times 3 plus 5.
20. 10.
And here we get a 10. All divided by 3 squared plus 4 times 3 plus 1.
22 squared.
22 squared. Now, would I put something like this on your quest? Would I put something like this on your quest?
Yes.
And the answer is no. Not like this, because now most people are going to want a calculator to figure this out. So I wouldn't put something that would require this. Even though we can kind of get away without a calculator, let me show you a little trick here. I'll break this into 2 fractions. 8/22 over 22 squared minus 20 times 10 over 22 squared. Now one of those cancel, and so I get 8 over 22. This gets a little bit more complicated. This is minus 20 over 22 times 10 over 22. This simplifies to 4/11ths. This simplifies to 10/11ths. And this simplifies to 5/11ths. And so after that point, I kind of have an ability where I can get in there and simplify that a little bit more. But would I make you do that on a quest? Would I make you do that on a quest? No, no. How many people get the idea though? How many people get the idea? So when I say average rate of change, what's the formula?
F of B minus F of A over B minus
F of B minus F of A over B. What are the units? Range over domain. When I ask for rate of change, when the book asks for rate of change, or I ask for instantaneous rate of change on a quest, what do?
Take the derivative.
Take the derivative. What are the units?
Range over
Range over
domain.
domain.
Range over domain. Is this making sense? This is making
Yes.
sense.
Yeah.
Okay. So geometrically, I don't know why I think if I just say it in the same monotone voice, that's good teaching. Yell louder. That's good teaching. That's high quality teaching here. Well, if you ask me, what's the applications of a derivative? Geometrically, it's the slope of the tangent line. But the biggest application is rate of change. It shows how the range is changing with respect to the domain. Do you think that's important, guys? Do you think it's
Yes.
important? Do you think it's important in biology, chemistry, physics, engineering, business, health sciences? Do you think it's important in health sciences? You know, I mean, just, you name a discipline, this is important to it. But a lot of people don't even know it. They take AP Calculus, and they're like, where's the application? And they don't even have any idea. And that, guys, for many of you, for most of you, this is your last math class. It started in kindergarten. And this is going to be your last math class ever. Does that put a lot of pressure on me?
A little bit.
Yeah, because how you think about math for the rest of your life could be negatively impacted by what I do, or positively impacted by what I do. If you tell your kids math is hard, I will haunt you from the grave. If you tell your kids you hate math, I will haunt you from the grave. Do you think math is going to get less important or more important in the 22nd century when your kids live?
I don't think it'll change. I feel like it'll be just as important.
That's.
Already so important.
Yeah, it's already so important. It
Do you
could
guys
be
have one of these?
also-
Do you guys have one of these?
Yeah.
That's
How does this work? Math. I mean, it's all, well, okay, now mine doesn't work, okay? So they said, do you think I can drop this?
He's
Will,
not.
will it break? I've never
Well, you
had
have
it.
a case on it.
I mean, it is also
but
carpet,
I
so
wouldn't-
probably
Yeah,
I'm worried if you hit like the corner of the table.
yeah, I just don't recommend it.
Because you can't fix it with math, you have to go to a place and.
You sound like my wife, Laura. You sound like, all the guys are like, drop it, Dr. Warren, come on, drop
What
it.
did they use to make the replacement parts?
No, thank you,
Looking
Mason.
out for you.
I thank you. Okay.
Use
Here,
it
you
as
can
a
drop
conflict
mine.
price. Don't drop the phone.
What am I looking at?
So your
Oh my gosh,
emails?
I'll just send you an email too.
Yeah.
Did Al just
Yeah.
send us emails?
Probably. It's election season. It's election season. I'm a political celibate, so
Just go vote.
I will vote. I will vote. Yeah, for myself.
For-
Not for myself.
Not for
I will
yours.
vote.
That was
Goes to the
more
ballot.
important.
Okay, let's just call this. Let's just call it over and out. Over and out. Okay. On Friday we meet where?
Downstairs.
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 In the basement.
Friday's a big day. Friday's a big day. It's a really important day of class. It's a really important day of class.
It is.
Yes. So if you can be there, be there. Nick.
Is there any way to like, do that personally, or is there like no way to do that?
There's no way, because I don't have this thing here. That's the problem. And the stupid desktop doesn't even have a camera. I can like hold up that stupid thing that you know, like they write paper, you know how they write and it projects on the screen? I've never used it
Those
ever.
are gold ones?
Well, they've got like, I don't know what, yeah, it's called an Elmo or something, they write here.
Oh, yeah.
I can show that, but it just doesn't work. It doesn't, it looks horrible with this camera, and this is $1,000 camera. So sorry, Nick, yeah, there's just nothing. I'll film it. So, you know, but it's hard to be in class. All right, guys, thanks for playing. Thanks for putting up with me.
Do you have tissues?
Now, what do we do about the grasshoppers?
Grasshoppers still alive?
Oh, did I call
Oh,
you?
yeah, how you?
No, he's fine. Don't hurt.
I can take it.
I'll take them out somehow. If
We
you
can
have
get them.
Alex is worried that I'm gonna get my hands on that thing.
Well, not your hands, your feet.
Yeah.
Here, you can do.
Body part.
You might as well use it, John.
The rag,
The rag.
if I can.
Go for it.
And
You
wash
need
my
that
face this guy all over.
Next to the green check mark, these are other class stuff.
That's our class now. That's right, you're from rural.
Aw, he's so scared.
Little baby. Yeah.
Wait, but where is it?
Oh, we know.
Oh, there it is, okay.
Don't switch.
I know.
I think that.
He's gonna go with it out.
Okay, he's in. Oh.
Yeah. Get a name.
Okay, I'll bring the rag.
Just open the window and then just chuck it out the window.
No.
Well, there's a screen there.
I don't think he'll survive that.
You trap him to a life.
We'll find him a nice bush.
Like I said, it's the Greek,
I hate bugs, Dr. Warren.
My wife hates bugs, my wife hates bugs.
I have an allergy to mosquitoes.
Oh, that must suck.
So, like, I'll get one bite and my leg will swell up like this, like that one bite will, so, like, I can wear clothes and they'll bite through my clothes. So to be fair, I have a justified reason,
That's-
to hate bugs.
That's,